All right. Good afternoon, everybody. Sorry about the late notice, but Blackboard was being a really pain today. It kicked me out several times. It took me about 10 minutes to log back in, and then it would kick me out again. So we're improvising. Okay, so we're going to do a recording for today. If Blackboard continues to be an issue, we may just start meeting in my Zoom room from now on, and I will share that link with you guys if necessary. Today, we're just doing an intro to circles. That's it. So this should be a relatively short video, recording, whatever. Doesn't really apply. Okay, so circles we've kind of talked about. We've talked about the area. We've talked about circumference, things like that. Okay, so in Unit 3, we are simply talking about circles. Sorry, I'm not used to Zoom, so give me a second. I'm not used to this. Okay, so we know what a circle is. We've done that before. We have a center point. We know what the radius is. Goes from the center to the edge. We know what the diameter is. Goes through the center from edge to edge. All right, so this one may be new. It's a chord. So a chord is a segment that connects any 2 points on the circle. So edge to edge. Doesn't have to go through the center though. Okay, so this one right here, this lovely blue line, is a chord. That blue line right there. I wish I had my pointer tool, but I guess I don't. I'm not, yeah, okay. So the diameter is a chord. The diameter is a chord. The chord does not have to be a diameter. Okay. So we're going to look at relationships between arcs and chords. Okay. We may get into some of these other terms. So a tangent is a line outside the circle that touches the circle at one point, and it's perpendicular to the diameter that intersects at that same endpoint. Okay. And then we have a secant, which is a line that goes through the circle in 2 places. So a chord is a line segment that touches in 2 places, the edge 2 times. A chord is a line that goes through and touches it 2 times, the circle twice. Okay, so in other words, we have arc, which is just basically part of the circumference, part of the outside edge. We have 3 types. We have a semicircle, which we've talked about, it's half the circle. Then we have major arc, which is bigger than the semicircle, bigger than half, and minor, which is less than a semicircle. Okay, so those are the 3 types of arcs we have. And then we have the central angle, which is basically any angle that is around the center of the circle, which in this one is point P. Okay. What is special about the angle, the central angle relationship and the arc relationship is if I know that this angle right here, I'm just going to say he's 100 degrees, right? Then I know that arc in KM, which I could just say is K or MN, is also 100 degrees. Okay, they just happen to be the same. We can find the arc measure in degrees, like I did here, or we can actually find the length in inches, centimeters, feet, whatever. And we'll be doing that in Unit 3 as well. All right, so I had planned on giving you guys access to whiteboard tools and letting you guys name some of this stuff, but I'll have to do it myself now. And I put this one on here twice. So I'm just going to cross it off. I didn't notice I put it on there twice. So a chord, we could say DC. I could say DG. I can even say the diameter FH. And again, those are line segments, so that's why I have the bar above. So the diameter, there's only one, FH. Radius, I have 2. I have AF and I have AH. And again, if you wanted to switch the letters around, not a big deal. All right, so a semicircle, again, there's always two. So we put this little arc above anytime we're talking about an arc. So I would say H, B, F, which happens to be the same as a DF. So anytime you're talking about an arc, you have to use at least two letters. If you use two letters, it's kind of the quickest path. If you use three, you're good. You don't have to use more than three. So H, I've used B, and B isn't even on the circle. Let's say C, because C is the point on the circle. So H, C, F would be this, very badly drawn, this semicircle. But again, it's the same thing as I said, H, D, F. It's still the same semicircle. So it has two different names. Again, you can switch the letters around and be okay with that. And then the other one then would be, there's really only one name for it, HGF. Again, I could switch the letters around. So H to G and then to F. Okay, I could say H to F as well, and that would work because the quickest path from H to F around the circle is the semicircle. That would work as well. All right, so a minor arc. I got lots of these. I could say EF. Definitely last. E is not on the circle. E is not on the circle. I could say FG, FG, or GF. Those are both on the circle. So this guy here, he's definitely less than the semicircle. Right? I could say GH. He's less than half a semicircle. I could say DF. I could say BD. I could say HD. Okay, anything that's less than a semicircle. So now the fun part when we're talking about a lovely major arc has to be bigger than a semicircle. So I'm basically going to start with my semicircle. So I'm going to say G, H, F. So G to H, and then all the way around to F. That's most of the circle, not all of it, definitely bigger than half. I could also say, again, I can move the letters around. I could say B, D, H. Make it a little bigger. That would work. So B to D and then all the way around to H. So again, there's lots of those. You just have to decide which one you want to do. The center point, of course, is just that, the center point. My center point is point A. Not a big deal. Okay. Being able to recognize the difference between a semicircle, major arc, minor arc, and a chord, big plus. All right. So again, having these relationships are important. All right. So my first question on problem 2 says if DF is 50, so DF, that's this piece here. What is the measure of 8 of arc HCD? So HCD. Okay, so I know that HF is my diameter, so HDF is 180. So I can say 180 minus the 50 is 130. So this guy would be 130 degrees. Again, there are 360 degrees in a circle, half is 180. All right, so next one says angle A or GHA is 120. What is the measure of arc GH? So again, here I only use two letters, and that's fine. That just means the quickest path, the quickest way. So again, if this is the central angle, then this is also 120 degrees. They're going to be the same. right, so your discussion, which opens today and closes Friday the 21st, it's worth 5 points, has you just your first post. All you have to post is the center, so a point, and a link for the radius. That's all I want. Okay. Then you're going to reply to 2 of your classmates. Okay. On one, you're going to say, hey, here's the equation I came up with for your circle in standard form. And then you're going to look for a second classmate that already has somebody who wrote the equation. And you're just going to kind of double check. Did they do it correctly? Is it correct? Or did they mess up a sign or something? But then you're going to graph. And you can graph in GeoGebra or Desmos. Take a screenshot and post the screenshot. That's what I'm looking for. And again, that'll give you your 5 points. So here's my example. Please don't use it. If you do, I'm going to be very irritated with you. Okay, so this is what I would post. This would be my post. My original post. Okay. So I just said I have a center at 1, -1, and a radius that has a length of 2. You can pick any numbers you want. I would advise you to be a little nice to your classmates just because they're going to have to do the work. So if you make your numbers too large or decimals or fractions, classmates may not be happy with you. Okay. So the standard form for a circle is right here. Okay. So the point, the center is HK. And of course, radius is R. So we have x minus h quantity squared plus y minus k quantity squared equals r squared. So for mine, this is h and this is k. And of course, r. So I plug them in. But if you notice, I have 2 negatives here, which I could then simplify into one giant plus sign. And 2 squared is 4. So this would be my first reply, or somebody's first reply. I would just write the equation. So then I use Desmos, or no, I used GeoGebra, sorry. I used GeoGebra to graph. And so this would be my second reply to a second classmate. When you do this, I put the equation, I put the center, I labeled everything what I needed it to be. You don't have to label anything unless you absolutely want to in the program. But again, take a screenshot, and this is what I want to see graphed. Okay, so there's our introduction of circles. Tomorrow we will be talking about chords and arcs and their relationship a little bit more in detail. Yay. And again, I will send you an email if Blackboard is still giving us trouble, which I have a feeling it will be. Yeah. So y'all have a good afternoon.